Hi, I'm Alex Pandrangi, if I don't know anyone in here. I focused on edge computing, specifically how leaders should evaluate investment. So my target audience is really executives who don't have a ton of baseline knowledge. If any of this is fundamental, I apologize for you. The roadmap of this presentation, I'm going to do a little preview, some of the key considerations and takeaways. Next, I'm going to level set what is edge computing and why should we care about it, and then I'm going to do a deep dive on each of the key investment considerations, and then a brief wrap up and hopefully a couple questions. So basically, I came down to 5 key takeaways that I want to go through in a little bit of detail. I'm not going to go through them too much right here, but I think a couple takeaways for me. For executives who really want to make decisions about, or at least thinking about their business in the context of edge computing and whether an investment makes sense, they really have to understand their data, the data of their business, what's truly critical to the business, and how the data interplays with their business. And it's not just on them, it's their team. They need to bring their team into the mix and work together to get to a decision that makes sense. And I've broken up the considerations. There's a few that are, the relationships are a little bit more clear, so if there's more of a given characteristic, then it makes more sense to think about edge computing. And then there's a couple that are a little more nuanced, cost and data security. So we'll get into that as we deep dive on each of those considerations. So first I want to level set. Edge computing has a lot of different definitions. I really like this one from HP. Edge computing is the practice of processing data near the edge of the network, closer to where the data is being generated, instead of in a centralized data processing warehouse. So I would think about if we're gathering a lot of data from a lot of different sources, we're sending it back somewhere. This is a more centralized model. So there can be challenges with that model. Edge computing is more, you're collecting the data in a number of places. You're able to process and analyze the data right near where you collect it, so you can generate insights and implement actions in a little bit more timely fashion. So the implications of this, there's certain applications where a centralized model has a lot of drawbacks and where edge computing can be particularly effective. And we'll definitely go into those in more detail. And there's other applications where it's not really possible to engage in them without some sort of edge computing capabilities. So it's a couple of interesting things there, and we're going to dive into the details right now. So first, deep dive around data volume and velocity of growth in data. I think we all recognize that across industries, more and more data is being collected. A lot of it's being analyzed, some of it's not really being analyzed. That's part of the issue. So collecting all this extra data, I think we're seeing a lot of bandwidth challenge. And along with bandwidth challenges, you see a lot of increasing costs. And like I said, a lot of this data is just being collected because now we can collect it. There are more smart devices, there are more sensors, more and more data is being collected. But this is creating additional load on networks, which bears additional costs. So I want to walk through a quick example here. I want you to consider a network of high-definition cameras on a university campus. If those cameras are recording nonstop and sending all this data back to a repository, that can be extremely expensive. Now, and that would be more of a centralized model. And then let's think about now a more edge model. If we could just increase the processing power of those cameras a little bit so they could run sort of human recognition or facial recognition algorithm where they only turn on and record and send back the data if they recognize a human being in the frame. Just a simple increase in processing power, a little bit of edge enablement, if you will, could decrease the amount of data sent over the network by 50 to 60%. A pretty interesting use case there. But what does that mean for business leaders in their own businesses? So basically the first question they need to ask is which data is really important to them? Because there's going to be a lot of data associated with their business, but what's really driving their KPIs? Secondly, what does the volume on that data look like? And how fast are those data streams, those critical data streams, actually growing? And there's a clear relationship here. If your data volume is increasing significantly and your data is growing at a high velocity, then those two factors can help make more sense for edge investment. Second, I wanted to take a dive into kind of the time sensitivity of the data for the actual decision-making process. So if you think about a centralized model, once again, you're collecting the data, you're sending it back to a repository, that's where you're processing it, analyzing it, you're generating some sort of insight. Something's being sent back somewhere for some sort of decision to be made. Within those different relays, you're increasing latency, there's additional time in all those steps, and that can be the difference between profit and loss or success and failure in many different applications. So let's just think about a very simple one. that really fits a latency challenge is high-speed trading. If you're trying to trade before the market incorporates some specific piece of information, long latencies are going to make that basically prohibitive. So in the business context, what leaders should be asking is exactly how time sensitive is the data that I'm generating? How is it processed? What exactly do the feedback loops look like, and how long are they? Another example, if I have a smart factory that is generating a ton of sensor data, and I have a process where I need to manage the temperature of a very high-end material, if that temperature drops a couple of degrees, within seconds that batch will be ruined. Well, the latency between sending that temperature reading back somewhere for processing and then back to change the temperature might be the difference between that batch being completely ruined or not. So there, if you could process the temperature and automatically make a change, you might have a better chance with edge computing. So basically, the shorter the feedback loop required to actually implement changes based on your data, the more that would support edge investment consideration. Thirdly, I want to consider network reliability. So basically, edge computing can allow the data processing of data processing that otherwise would be interrupted if a network connection is lost. So there's certain use cases where public cloud is just not really an option because potential network reliability issues. So let's think about a common example of autonomous vehicles. So clearly, if you lost some sort of network connection and you lost a lot of the functionality of the autonomous vehicle, this would be very unsafe for your passengers. So that use case really doesn't work without significant edge capabilities on board the actual vehicle itself. So leaders need to really ask themselves, in what environment is my critical data being collected, and how reliable is that network infrastructure? So naturally, the more rugged the environment or the less reliable the network, then those factors would favor edge investment consideration. So then the next two, cost and data security, are a little bit more nuanced. So I think in cost, it's easy to think about on an ROI basis. So back to the camera example, if we wanted to change those cameras and have them have more processing power kind of at the edge where they're collecting the data, there'd obviously be a cost to adding that processing power. But then we'd obviously hopefully realize some sort of gains on the decrease in cost of transmitting data because we're not transmitting as much data. So you can kind of make some calculations based on those upfront costs of outfitting those cameras with more processing power versus the savings that we're generating through the decreased data transmission. But with the applications that are completely edge enabled, where you can't pursue them without edge capability, it makes it a little more difficult because you don't necessarily have historical context or data to make more reasonable assumptions. So basically, there's a lot more uncertainty, and you have to make broader assumptions. And you just have to be, as a leader, I think you have to be willing to undertake that risk. Another factor with cost is some of these applications, like maybe search and rescue apparatus or even autonomous vehicles, have an inherent safety component, and that can be very difficult to incorporate into the cost equation. So that's something that leaders should bear in mind. So you have the safety concern, and then you can, though, generally think about kind of the incremental ROI of an investment, or if you don't have kind of that historical context, or you're not just thinking about an upgrade, then you could think about the overall project ROI, where that might be a little bit more uncertain given the additional assumptions. But theoretically, the additional ROI would favor increased edge investment consideration. And then potentially even more nuanced is data security. And this is a bit of a tougher one. So at the edge, you're gonna be collecting a lot more data. It's gonna be processed there. It's gonna be stored longer there. So on the negative end, you have a lot more access points for potential attackers. You have potentially more vulnerability because if you're, say, for example, you're maintaining the same level of security resources, they're now spread across a lot more potential access points. So you're potentially more vulnerable there. However, from a positive side, your data is now potentially much more narrow at each vulnerability point versus if someone were to access, say, a central repository with all your critical data. So there's both positives and negatives in terms of data security and moving to a more distributed or edge-focused model. And in this one, I think leaders really need to be aware of their limitations and really talk through this with their cybersecurity experts and bring them into the loop kind of as soon as possible. And I think the net effect is really unclear. It depends on the application. It probably depends on the specifics of the organization and such. So those are the 5 key things that I really wanted to highlight that I think are important for leaders to think about. Again, I think the takeaway is really leaders need to understand their data, the most critical data for their companies. They need to understand their IT environment to some extent, and where they're limited in these things, just bring in the people at their business who do know them and make it a team effort. It's very early days for the edge in general, so I think that over the next few years or decade, I think this may become much more relevant for a lot of different industries. But I think it's early days now, and I hope some of these considerations and key questions can help folks think through it. Thank you. Any questions?
Yeah, so Microsoft has invested a lot in the edge. It's been a core strategy for them, and they've also heavily tied that into their mobile strategy. During your research, did you come across other budding areas of investment outside of mobile where edge computing can take place? Like, I love the camera example, but are there other either pieces of hardware or areas that you see edge computing being embedded?
I mean, I think the most built-out piece of it is probably in kind of the smart manufacturing or heavy industrial spaces, because a lot of those processes are very resource intensive and can be extremely expensive because of that. So very small variations and fluctuations in real time can make hundreds of thousands of dollars or millions of dollars of difference. So that's where I think today that's where it's most built out.
So we kind of seem to go through these phases where things get pushed to the edge, brought back to the middle.
True.
We had that with ERP, and then it went back more distributed, and then cloud kind of brought everything more centralized again, and edge seems to be pushing it back out. Do you have any sense of why that goes on, or how this plays into that longer term kind of oscillation that happens in technology?
It's a tough question without thinking more about the longer term historical context. I'd have to think about it.
Sure.
Yeah. Let's flip that question. So suppose just the opposite. Suppose we were in a situation where everybody was doing edge. When would you say that they would go to? When would you use a more centralized model? So let's, because in part this is sort of the install logic is centralized. Now we're trying to figure out when to do edge. If we flip that, and let's say everybody was doing edge, when would you tell people to centralize? Like what are the key?
Well, it'd essentially be the opposite in terms of the first 3. And I think why part of the reason that I could see a shift in the coming years is because things are becoming so much more complicated. We're having to deal with so much more data fundamentally that we never have before. I think if things reversed and that there's businesses where you've really streamlined your data up front, whereas you're only collecting very specific fundamental pieces of data, you're only working with small amounts of data, that data is not, for whatever reason, super time sensitive, and you have the luxury of performing kind of all your analytical functionality in a central place, and it's maybe super sensitive data where you want to focus all your energy on establishing an incredible security defense of this one place. Those are the sort of things, it's kind of the opposite of the things I walk through, but that's what I would think about. And because that is seeming like a less and less complex world, it makes me think that it's less likely in terms of a trend.